In this video, we'll look at how to do reduction in trigonometry. But before we do that, just a quick reminder on how to do mathematics. Number and copy the examples. Ask your tutor or teacher if there are any steps that you do not understand. Number the questions. Unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your answers. If it is incorrect, write down the corrections. Make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now, to get started, we have our Cartesian plane, and what we want to do is we've got sine 180 degrees plus theta. So we want to apply the reduction formula on this and then simplify it. Now, the first thing we look at is this 180 plus theta, and then we decide in which quadrant is it. So 180 plus falls in this quadrant, in the third quadrant, and after we've decided or established if it's in which quadrant it is, then we need to say is sine positive or negative in that quadrant. So this is Tan's quadrant, so it's going to be negative. And then finally, all we need to do is just to write down the sine and the trig function. So we know it's negative, and then it's just sine theta without the 180. And that's how we apply the reduction formula. Now for our next example, this is when you either have 90 degrees or 270. Then you're going to make use of your co-ratio. So first of all, the normal step was to establish in which quadrant is 270 degrees plus theta. So 270 plus falls in cos's quadrant. So then we can say is cos positive or negative in that quadrant. So it's positive. And then we write down the sine and the co-function. So this always happens when it's either 270 or 90. You have to write down the co-function. So this is then, we've seen cos is positive in that quadrant, and then this is going to be sine theta, because sine and cos are co-functions. So now for the actual examples of what we can expect in the tests. So we have the following, and we need to apply or simplify the following expression. So we start one by one applying the reduction formula. Now we have cos 180 plus theta. So 180 is in Tan's quadrant, so that means cos is negative in that quadrant. So this becomes negative cos theta. And then sine 90 minus theta. Now 90 minus theta, everybody is positive there, but this is now 90. So between 90 and 270, we write down the co-function. So this is going to be cos theta. And then this is over. So here we have cos minus theta. So if this is plus theta, then this is minus theta. So minus theta falls in the fourth quadrant, same as 360 minus theta. Then this becomes so cos is positive in that quadrant, so it becomes just cos theta. And then for tan, 180 minus theta, so 180 minus is in this quadrant, and that's sine's quadrant, so tan is negative in that quadrant, so it's minus tan of theta. And then finally cos 360 minus theta, so 360 minus theta is in the fourth quadrant, so that is cos's quadrant, which means it stays positive there, so that's just cos theta. Alright, so all that we need to do now is to start by simplifying, and we can see that this minus and minus can cancel. This cos and cos can also cancel, and then these two can cancel, so we are basically left with 1 over tan of theta. Okay, so now for question 7.1, and we have sine 180 minus theta, so 180 minus falls in sine's quadrant, so it's going to be positive there, so it's sine theta. Then 360 minus theta falls in cos's quadrant, so it's also going to be positive there. Then tan 360 plus theta, so 360 is a whole revolution, and then plus theta is just in the first quadrant therefore. So everybody's positive there, so this just becomes tan theta. This is over. Alright, so now, as you can see, this is theta minus 180. So normally we have the 360 or 180 in front of the theta. So what we need to do now is we need to swap these two around. So what I do is I say, okay, this is going to be then sine minus 180 plus theta, because remember, if I swap terms around, I have to take the sine with, and then I need to factor out the sine. So this becomes sine, then the minus comes out, 180 minus theta. So where is, if I only have sine minus x, that's going to be in this fourth quadrant, then it means that sine is negative there. So this sine minus x becomes minus sine x. So if I bring this minus, if I apply the reduction formula to simplify this minus out, this then becomes minus sine 180 degrees minus theta. Alright, so then I can apply the reduction formula once I've taken out the minus. Now you can do this if you have a theta minus 180, if it's a negative in between, you can basically just swap them around and then decide whether, if it's sine, you have to take a minus out, sine or cosine, sine or tan, you have to take a minus out. If it's cos, you can just swap them around. There wouldn't be any changes, because if I have cos minus x, then this is still in cos's quadrant, so this will still just be cos x. Okay, so applying the reduction formula here, we've got 180 minus, that is in sine's quadrant, so this will then still remain the same. We're just going to have minus sine, because this minus was taken out from the previous reduction formula, so this is minus sine theta. Okay, and then to simplify that, we cancel out the sines, and then we can change this tan theta into sine over cos. So I'm going to just bring through my minus, and then I have cos theta. I can put the minus at the top or at the bottom. Then this becomes sine theta over cos theta. So this will then cancel, and my final answer will then be minus sine theta. Question 7.2, simplify the following. We start off with the first one. We've got cos minus x, so this is then in cos's quadrant, so this just remains positive, cos x times, so sine tan 180 plus is in tan's quadrant, so it remains a positive tan x. Then we have x minus 360, so as we've seen earlier, we can swap this around, so this will then become, and we can take out the minus, so this will become minus tan 360 minus x. So now to apply the reduction formula on this part, we have 360 minus is in cos's quadrant, so if I take out, if I reduce this part over here needs to be negative. So we're going to have this negative that came out from the first reduction when you take out a negative, and then we have the negative from the reduction 360 minus. So this is then minus tan x over then cos 180 plus x. 180 plus x is in tan's quadrant, so that's going to be negative cos x. And then tan minus x, so negative x or minus theta is in this quadrant, so this is going to be minus tan x. Okay, and then let's see what we can cancel. We can cancel the coses, we can cancel the tans, and then this minus times a minus is a plus, and this minus times a minus is a plus. So we basically just left with tan x. Question 7.3. So this one looks quite complicated, but we'll just take it one step at a time. Now the first expression here, we've got tan theta, theta minus 180. Now this one needs to be swapped around. So this then becomes negative. So this one becomes negative tan 180 minus theta, because we've swapped the signs around, and then we use the reduction formula from tan minus x becomes minus tan x. Right, so this then, if I can just write that here, minus tan for now, tan 180 minus theta. And then over here, we've got 900. Now, cos's period, every 360 degrees, it does the same thing again, because the graph has, it goes, and then every 360 degrees, it repeats itself again. So we can actually take any degree and then add or subtract 360 degrees, and then we'll get to the same point over here and over here, for example. So if I put that into the calculator and I say 900, and I just keep on subtracting 360 until I get to something that's less than 360. So this is 540 and minus another 360, then 180. So instead of 900, I can use 180. So I'll say that is then cos 180 plus theta, 180 degrees plus theta. Now for this part over here, we know sine theta, so this is minus theta, so this becomes negative sine theta over there, and then minus, then we have squared. Now this expression, if I have cos squared theta, this is the same as cos theta all squared. This is just the notation that we use, but this is what's actually happening. Now I can rewrite that as cos 180. Now if I reduce this one, 180 minus theta falls in sine's quadrant, so this then becomes negative cos theta, and that's all squared. So this square is actually going to get rid of this minus when I square this expression again, and then that's over cos 90 minus, so this I have to swap around, so then I write it as cos 90 minus theta, and then when I've taken out the negative, so minus x, so if I say cos minus x, this is just because minus x falls in cos's quadrant, it stays positive cos x. So if I take this minus out, it's going to stay positive, so cos 90 minus theta. Right, then for this next step, so this one I can now apply the reduction formula on. 180 minus theta, that's in the second quadrant, so that's sine's quadrant, so it's going to be a negative tan theta, and then so we've got a negative here on the outside and on the inside, and then cos 180 plus theta, so cos 180 plus is in tan's quadrant, so it's also going to be minus cos theta, and then we have minus sine theta over there, and if we square all of this, we get plus cos squared theta over 90 minus theta is in the first quadrant, but now since we are dealing with 90, we have to write down the co-ratio, so this becomes sine theta. Right, and then we can simplify on this outside also. This minus and this minus will cancel each other, will become 1. A plus, a positive, minus and minus becomes positive, but this minus I can bring to the front, so this becomes minus. So this is now this minus, and then this I'm going to change to sine theta over cos theta times by cos theta. And then on the inside, I'm just going to leave that as is for now. And then this will cancel. Because what I'm going to do now is I'm going to multiply this minus sine theta into my brackets. So if I multiply in a negative sign, this negative and this negative becomes positive. This sine theta and sine theta becomes sine squared theta. And then once again, I multiply this term with the second term, and the minus and minus becomes a plus, the sine theta will cancel with the bottom sine theta. So this is then going to be plus cos squared theta. And this we know as the identity sine squared theta plus cos squared theta is equal to 1. And now if we go over to this type of example, now these ones only contain degrees, so we don't have theta or x or any variable. So how we deal with these, we look at our degrees, and what we need to do is we need to break up the value, and we need to break it up into one of two values. The first one is either the 90, 180, 270 or 360, and the other value is plus or minus your special angle. Special angles meaning the 30 degrees, 45 or 60 degrees. So if I look at my quadrant, let's look at this example. Then I see, where does 210 fall? So 210 falls between 180 and 270. So that's going to be somewhere there. Then I need to always start first, look if either 180 or 360, this value can be broken up into one of those two plus or minus a special angle. Because if you use 90 or 270, you have to get the co-ratio when you do the reduction formula. So let's see, what is 180? So if 210 lies over here, then I add, from 180 to I add 30. So that means that I can break this up into 180 plus 30. Now I've used one of these four, and I've used this, and 30 is a special angle, so this will work. So now we just go according to what we've done previously, where we've applied the reduction formula. So we have tan 180 plus is in tan's quadrant, so it stays positive, so it's tan 30. And then to simplify this, we need to go back to our special angles where we had the triangle. So in this case, we're going to use the 60 degree triangle, where this was 1, 2, and 3. And then we know tan is opposite over adjacent. So from 30, we've got opposite over adjacent. So this is then going to be 1 over the square root of 3, and that's our final answer. Now to look at example 8, this is how we can expect those type of questions. So once again, we're just going to do it one expression at a time. Now tan 210 we've just done in the previous one. We've broken that up into 180 plus 30. So this one is then tan 180 plus 30 degrees. Then the sine 240. So 240 falls also between 180 and 270. So from 180, what must I add to get to 240? I must add 60 degrees, and 60 is a special angle, so I can change that into 180 plus 60. Then sine, now 170 is over here. Now this looks like a random one, because if I say 180 minus 10, 10 is not a special angle. 90 plus 80, and 80 is also not a special angle. So neither of these are really going to give me a special angle, but this is something that normally happens, and then you normally cancel. So one at the bottom is also going to be random, most probably. Then you will reduce this one, and then one of the bottom ones should also reduce to something similar where they can just cancel. So let's just look if we say that if we change sine into 180 minus 10, just to simplify it to something smaller, we'll see if we can change something at the bottom to look similar. Then cos 135, so that's 180 minus 45. So 45 being a special angle, we can do that. So cos 180 minus 45, and then sine 225, so that's 180 plus 45. So this becomes sine 180 plus 45. And then cos 100. So we know 90 plus 10 gives me 100. So that kind of looks like the right thing, because we've got 10 over here. So let's change that 100 to cos 90 plus 10. Okay, so now to apply the reduction formula, we have 180 plus 30 is in tan's quadrant, so it's going to stay positive tan 30. Then sine 180 plus is in tan's quadrant, so this is going to become negative sine 60. And 180 minus is in sine's quadrant, so this is going to stay positive sine 10. Then cos 180 minus is in sine's quadrant, so this becomes negative cos 45 times by, so sine 180 plus is in tan's quadrant, so it becomes negative sine 45. And then applying the reduction formula on cos 90 plus, now 90, once again I have to change it into its co-ratio. So 90 plus is in sine's quadrant, that means that cos will be negative there, but now since it's 90 I change it into its co-ratio, so I change it into sine 10, and as you can see these can now actually cancel out. And then just to sort out the signs, we've got a negative and a negative over here that can become positive, and then we've got this negative and negative. If I divide them, they become a positive. So all the signs basically cancel out, and now we just need to use our triangle. So we've got our 30 and 60 degree triangle with 1, 2 and 3, and then we've got our 45 degree triangle with sides 1 and the hypotenuse side square root of 2. Alright, so for tan 30 we go from the 30 degree angle, and tan is opposite over adjacent, so it's 1 over square root of 3 times by, now sine 60, opposite over hypotenuse, square root of 3 over 2, and then this one has cancelled out. So now we have cos 45, it's adjacent over hypotenuse, so that's 1 over the square root of 2 times by sine 45 is opposite over hypotenuse, so that's 1 over the square root of 2. Now to simplify, we cancel these two, so this is a half, and then 1 times 1 is 1, square root of 2 times square root of 2 is just 2, and this then gives us 1. Question 8.1, simplify the following without the use of a calculator. So here to start off with, we've got sine 10 again, so I'm just going to write that down because I cannot change it into 90 minus 80. That's also not a special angle, but can you see there's a 80 over here? So I can perhaps change it, or I can actually choose to change any of these two, because this will then become this will become sine 10. If I change that one, it can become cos 80. So either way, they're going to cancel. Now cos 120, we have, if we start from 180 plus what or minus what, we need to, because 120 lies between 90 and 180. So 180 minus 60 gives me 120. So I can break that up into 180 minus 60, because 60 is a special angle. And then cos 80, we said we can break that up into 90 minus 10. So cos 90 minus 10. And then sine 150, that's 180 minus 30. So sine 180 degrees minus 30. So now to apply the reduction, this just stays sine 10. 180 minus is in sine's quadrant, so cos is negative in that quadrant. Negative cos. I put this in brackets so that I remind myself that it is times, not subtracted, because if I don't use the brackets, it's going to look like I'm going to say sine 10 minus cos 60. And then cos 90 minus 10, so that's positive, but then cos 90 will change it into its co-ratio, so this becomes sine 10 times sine 180 minus 30. 180 minus is in sine's quadrant, stays positive, it becomes sine 30. So these two will cancel, and then to substitute in the values for cos 60. So if I have my 30 and 60 degree triangle here, 1, 2, and 3, then cos 60, cos is adjacent over hypotenuse, so this is a half, over sine 30 is opposite over hypotenuse, so this is just a half. So these halves cancel, and I'm just left with minus 1. Question 8.2. Now, here we have squares again, so I'm going to rewrite it with the square on the outside. I'll put brackets around my whole expression. So this is going to be 3, and then I've got inside, I've got sine 150. Now 150 I can change into 180 minus 30. So this becomes sine 180 minus 30 degrees, and that's squared, plus 2. So this is then sine 225 to 225 is 180 plus 45. So this is sine 180 plus 45. That's all squared. Minus, now cos 360. So this is another one where we used the function, also special angles. So if I have my, okay, that's a sine graph, sorry. If I have a cos graph, it looks as follows, where this is up to 360. So 360 degrees is at 1. So this whole expression just changes to 1. So this is minus 1, and then minus 2, and then just to put the square outside. So 330 is 360 minus 30. So this is cos 360 minus 30, and that's going to be all squared. So now to apply the reduction, this is then sine 180 minus is in sine's quadrant, it stays positive, sine 30, plus 2, 180 plus 45, and that is 180 plus is tan, so this is going to become negative sine 45, and then minus 1, that's squared, minus 1, minus 2, so cos 360 minus 30 is in cos's quadrant, so it stays a positive there, and squared. So now just to apply our squares. Now all that this is actually going to do is whenever something is negative, it's basically going to stay positive, because 2 negatives gives us a positive. So this is then 3. But actually, before we apply the squares, let's substitute our values in for sine 30. So if we have our 60 and 30 degree triangle, 30, 60, 1, 2, and 3, then sine 30 opposite over hypotenuse becomes a half. So this is all squared, plus 2. Then we have minus, now sine 45. Just draw this 45 degree triangle over here, 1 and 2. Then sine 45 opposite over hypotenuse is 1 over the square root of 2. That's all squared, minus 1, and then minus 2. So cos 30 adjacent over hypotenuse, so that's square root of 3 over 2, and that's all squared. Now we just simplify these. So this becomes 1 over 4. This is 3. And at this point, you can actually put this in your calculator just like this. Plus 2. So this squared, that becomes a positive. This stays 1, and that becomes just 2, because the square roots and the square will cancel. So this is just a half. Minus 1, minus 2. Then this square root cancels with the square, so this is just 3, and then that's 2 squared, which becomes 4. So here we have 3 over 4 plus 1, because if I put the 2 over 1, these two will cancel, minus 1 minus 2 So I'm not going to cancel these because I want both the denominators to be 4. So this is then minus 6 over 4. So this plus 1 minus 1 becomes 0. But then we have 3 minus 6. So that's minus 3 over 4. Question 8.3. Simplify the following without the use of a calculator. So tan 315. So if I have 360, I can say 360 minus 45 gives me 315. So this is then tan 360 minus 45 plus cos 300. Now this one is 360 minus 60. So I can change that into cos 360 minus 60. And that's over sine 150. 150 lies in sine's quadrant, so that's 180 minus 30 can give me 150. So this is sine 180 minus 30 degrees plus tan 135 is 180 minus 45. So this is tan 180 minus 45. To apply our reduction formula, so 360 minus is in cos's quadrant. That means tan is going to be negative there. So this is tan 45 plus, so cos 360 minus cos's quadrant, it stays positive there. And then 180 minus is in sine's quadrant, it stays positive there. So this is sine 30. 180 minus sine's quadrant, tan becomes negative. So minus 45. Tan 45. Now our special angles, I've got 2 triangles that I now need to draw again, and 45 1 1 and square root of 2, 60 and 30 1 2 and 3. So for tan 45 I've got my negative there. Tan 45, tan is opposite over adjacent, so that's 1 over 1, which is just 1. Plus, or let's put it as 1 over 1, plus cos 60. So cos 60, cos is adjacent over hypotenuse, so that's plus a half, over sine 30. Sine is opposite over adjacent, opposite over hypotenuse, that's a half, minus tan 45 again, opposite over adjacent, so that's 1 over 1. Alright, so here we have, actually we could have just said that's 1, so let's say that's minus 1 plus a half, and then this swapped around is also equal to minus 1 plus a half. So this will initially cancel top and bottom, so our final answer is just 1.